Not an actual claim there, not a statistical analysis of the exams, just in my experience. All right, we're going to move on to F1.1, which is interest and depreciation. This is the first part of our financial unit. This is the syllabus dot points. I'm going to give you a second to have a look at these. So you can see we're looking at percentage increase and decrease, simple interest, goods and services tax, depreciation. We've got a depreciation formula, and we're also going to have, there's also a mention of recurrence relations, not very important. All right, so some definitions. Percentage increase in financial, the percentage by which something will increase in value. Percentage decrease, a percentage by which something decreases in value. So if there's something's on sale, it's on a percentage decrease. If something's been marked up, it's on a percentage increase. GST is the goods and services tax. So everything that you buy has a 10% tax included called GST. It's just to basically tax the cost of goods and services. Simple interest is the interest that does not compound. So we're talking about interest using the formula I equals PRN. Interest equals principal times rate times number of time periods. Depreciation is when something will depreciate or decrease in value over time. When you buy a car, it often goes down in value over time. All right, so we're going to look at something that experiences a percentage increase. So this is a jacket that increases in price by 50%. So it originally cost $80. So to find the percentage increase, we add the percentage to 100% because 100% of 80 is $80, right? So if we want to go up by 50%, we have to do 150% of the price. We add our percentage to 100% already. We don't just times it by 50% because we get half if we did that. So the jacket has increased by price by 50%. It's now $120. So now we can do the opposite. The $80 jacket is now on sale. It experiences a percentage decrease of 25%. So we now minus 25% from 100, which would be $80, to find 75% of the value. So 80 times 75%, our value is now $60, which is 75% of the original $80 jacket, or a percentage decrease of 25%. Okay, simple interest. Very, very important you understand this formula. It's the amount of money that accrues based on how much money you put in the bank. So say you have $2,000, you give the bank $2,000. They're going to calculate simple interest, if that's what you elect to do, on that $2,000 in, indefinitely. So they're just going to keep doing it unless something happens to the investment, there's a closure period, whatever it is. They're always going to calculate interest on the original amount that you invested. So even if you add more money, the interest is still going to be calculated on $2,000. And even when you earn interest, the interest is still going to be calculated on $2,000. So it doesn't matter if the account gets up to 10 grand with all the interest you earn. It's still going to be calculated on $2,000. This is simple interest. So I equals interest. P is the principal or the money invested. R is the interest rate, which is usually expressed in a percentage or a decimal point. And N is the time period. So how many times over is the money going to be calculated, or the interest is going to be calculated. So Kayla invests $7,000 into a simple interest account for 3 years at a rate of 4% per annum. We always underline our 3 pieces of information: principal, number of time periods, rate. So now we plug that into our formula. $7,000 times a rate of 4% per annum. We're going to convert our rate to a decimal. It's easier to put that in like that. 0.04 times 3 years. We then get $840 of interest. That is not the value of the investment. That's how much interest the bank has paid her. Okay, so depreciation refers to something that is going down in value. I'm going to use Lightning McQueen here. Let's say he depreciates, this would never happen because Lightning McQueen would never depreciate, but let's say he depreciates in value by $450 per year for 3 years, starting at $70,000. So we have a formula here. Salvage value. So think of a car lot where they like salvage cars for parts. Salvage value, our final value after all of the depreciation, is going to be VO. Don't worry about the O, it's just V. Minus depreciation times number of time periods. So his original current value is $70,000. minus depreciation of $450 per year for 3 years. His salvage value, he's going to be worth $68,650 at the end of the 3 years. All right, we're going to do a couple practice questions now. So calculate the simple interest on the following investments. $4,000 invested for 6 years at 8% per annum. So to do this question, we have to do I equals PRN. So interest equals $4,000 times the rate, which is 0.8%, times 6 years. We put that in our calculator. We get $1,920 of interest. Next question. $2,800 is our principal, invested for 3 years at 0.025%, 3 years. 2,800 times 0.025 times 3 years, we've earned $210. This shows you the difference between interest rates, 8% versus 2.5%. Now, this one's important to understand. $7,800 invested for 5 years at 4%, calculated every 6 months. Number one, it doesn't say per annum, so we're going to understand that this is a 6-monthly interest rate. If it was 4% per annum, calculated every 6 months, we would have to divide it by 2 to get our 2-monthly rate. But because it doesn't say per annum, we're just going to write 4%. Every 6 months for 5 years, so there's not 5 time periods, there's 10, because there's 10 lots of 6 months in 5 years. So 7,800 times 0.04 times 10. 7,800 times 0.04 times 10. And I get $3,120. Okay. We've got those notes there. It does not say per annum, 6 monthly, 5 years. All right, we now have a table of interest rates we're going to complete. So we've been given one interest rate for each of them. So we're going to try and work down from our first piece of information. So if the 6 monthly rate is 3%, we can assume that the annual rate would have to be double that, right? 6%. If the annual rate is 6% and we want quarters, we're going to divide by 4. 6 divided by 4 is going to be 1.5%. And if we want the monthly rate, we're going to divide 6 by 12, which gives us 0.5%. Now we have a monthly rate, 0.4%. We're going to divide by 4 to get 4 months, which is, by 3 to get 3 months, which is a quarter. So we get, hang on, I've got to go back to this one then. Let's see if I can erase. I've just realized I've done this one wrong. So we have an annual rate of 6%. Oh, actually, no, I think I did it right. We have an annual rate of 6%, quarters, 6 divided by 4, 1.5. And our monthly rate, yes, we need to go 6 divided by 12, so 0.5. Second guess myself for a second there. If we have a monthly rate of 0.4, we can divide it by 3 months to get a quarter, 1.2. If we have 0.4, we're going to divide by 6 to get 6 months, 2.4%. And then we divide that by 2 to get the annual rate, 4.8%. This one, annual rate 10%, so 6 monthly rate is going to be half of that, 5%. We then need a quarter of our annual rate, so 10 divided by 1 quarter is going to be, or 10 divided by, we can go, there's 4 quarters, so divided by 4, 2.45%. And then we want a monthly rate, so we can do 10 divided by 12, and we get 0.8%. Last one, if the quarterly rate is 4.5%, 4.5 times 4 quarters is going to be 18%. Half that for our 6 monthly rate, and then 18 divided by 12 is going to give us our monthly rate. This is really, really important stuff to understand because so many of your questions will give you $7,000, 4% per annum, compounded quarterly. You need to break that 4% down into 4 quarters to get that 1% interest rate. If you don't make these changes when you practice these questions, you will not get the question right. We've got all of our answers there as well. Okay, a car is purchased for $45,000 and depreciates at $800 per year. How much is it worth after 5 years? Oh, ignore that. Okay, so we have our salvage value equals our current value minus depreciation time periods. Salvage value is going to equal $45,000 minus our period of depreciation, which is $800 per year for 5 years, so times 5. Pop that into our calculator. 45,000 times 800 or minus 800 times 5 gives us $41,000. Other question, a house is purchased for $1.2 million and depreciates at $18,000 per year. This is very uncommon for houses, but let's say the wear and tear is serious. 18,000, 20 years. 1.2 million minus 18,000 times 20. The house is now worth $840,000. Take a look at these questions. We have our 2 answers here. All right, we're also going to find the percentage increase from a couple of different amounts. So how do we find the percentage increase? We need to find the difference between the two as a part of the first. So $200 to $260. The difference here is $60. We need to find how much 60 is of 200. So 60 over 200 gives us 0.3, which means it was a 30% increase. Now we can test this by doing 200 times 130%, which gives us 260. Next one, the difference there is 4 meters. 4 over 10 is going to give us 40%. So our percentage increase was 40%. All right, 45 liters to 67 liters. We need to find the difference. 67 minus 45 is a difference of 22 liters. We have to divide by our original amount, 45. 22 over 45 is 0.48. So we're going to say a 48% increase. 53 minutes to 90 minutes. We're going to find our difference. 90 minus 53 is 37-minute difference. Divided by 53, 37 divided by 53 is 0.698. So I'm going to go 70% increase. We have all of our answers there. Oh, I've just realized my original answer was wrong. This is wrong. 53. But yes, all of our answers, 30, 40, 48, and 70. Correct. All right, calculate the GST included within the post-GST prices. So when we're finding GST, we need to, if it's currently got the GST in it, we have to take the amount of money that includes the GST, divide it by 11 to find that 10% tax. Because it's 10% of the original price, so there's technically 11 parts. So $670 divided by 11, 670 divided by 11 gives us 60.9. So I'm going to go $61. $321 divided by 11 is going to give us 29.18. So I'm going to go with $29. $38,096. 38096 divided by 11 gives me 3,463.27. And then 123.68 divided by 11, 123.68 divided by 11 is $11.24. So we'll just go with $11.24. So this is the GST added into these prices. So you can find the no GST, you can find the original price by going with the cost. So 670 minus GST would be the pre-GST price. Apologies for the very shoddy handwriting. Okay, over 7 years with an interest rate of 6.5%, $4,049.50 of interest is earned. Calculate the original amount of money invested. So our formula is I equals PRN, right? We now have the I, $4,049.50 equals principal RN, which we know, if we actually write them in, is going to be, we're looking for the principal, calculate the original amount of money invested. We know that the rate was 0.065, and we know that it was over 7 years. So how are we going to do this? We're going to change the subject of our formula. The first thing I'm going to do is 0.065 times 7. So we know that it's this times 0.455. Now, if I want to move this to this side of the formula, I have to divide it by itself, which erases it from this side. We just get left with P, and we have to divide this by 0.455. So 4049.50 divided by 0.455 gives me 8,900 equals P. So the original amount of money invested was $8,900. Like that. All right, so how do we get all of our questions right? How do we smash interest and depreciation? Number one, read the question very, very carefully. Is the interest rate per annum, but the time period is months? You have to be able to pick out whether it says per annum, months, quarterly, daily, monthly, biannually, whatever it says. Always clarify what your final answer was. So were you asked to find the interest? Were you asked to find the investment plus the interest, the original investment? It's very important to double check that. And remember those interest and depreciation formulas. All right, what do you include on your summary sheet? Examples of percentage increase and decrease, GST, simple interest and straight line depreciation, and then compound interest as a recurrence relation. This is very rarely tested. That's why I didn't even bring it up to you guys, because it is literally just doing simple interest over and over again to figure out compound interest, which you'll do compound interest in year 12 anyway. These underlined parts very much are on the year 12 exams that I see.